Mobile carriers are deploying IPv6 only networks, but there's a critical problem. Millions of applications and services remain IPv4 only. How do we bridge this gap efficiently? The name says it all. 464 represents the journey from IPv4 to IPv6 and back to IPv4. It combines stateless translation at the customer edge with stateful translation in the provider network. This enables transparent IPv4 connectivity without tunneling overhead. Let's examine how 464 XLAT works. The CLAT performs stateless NAT46 translation, implemented as a daemon on mobile devices or as firmware on customer routers. When an IPv4-only application sends a packet, the CLAT translates the IPv4 header to IPv6 without any encapsulation. The CLAT translates the IPv4 source address to an IPv6 address. The IPv4 destination is translated using the PLAT's configured prefix. The translated IPv6 packet traverses the provider's IPv6-only network to the PLAT, routed like any other IPv6 traffic. The PLAT receives IPv6 packets from multiple CLATs, performs stateful NAT64 translation to IPv4, and forwards them to the IPv4 Internet. The PLAT maintains stateful NAT64 bindings, mapping each customer's IPv6 address and port to translated IPv4 addresses and ports, enabling correct routing of return traffic. Here's the complete end-to-end flow showing the 464 transformation. An IPv4-only application thinks it's on a regular IPv4 network, but its packets undergo two translations. Stateless NAT46 at the CLATs transit through the IPv6 backbone, then stateful NAT64 at the PLAT. Return traffic follows the reverse path. 464 XLAT excels in several critical scenarios. One example is for mobile carriers deploying IPv6-only networks while maintaining app compatibility. The second example is for broadband providers offering IPv6-only access services. The ISP supplies or updates customer equipment with CLAT functionality, eliminating the need for customers to purchase new devices. 464 XLAT eliminates the complexity of dual-stack networks, uses efficient protocol translation instead of tunneling, and provides transparent operation for all IPv4 applications.